Okay, hello everyone. Let us now proceed to graphing rational functions. Now, there are many steps in manually graphing rational functions, and we will enumerate them as we go along. Okay, so you might be wondering, why do we need to manually graph them when we can graph them automatically using a different web apps or different software? The answer to that is it's also good to know how to graph them without the aid of the software. And if you have access to them or if you're allowed to use software, then definitely use them. So why not? Okay. So let's start with the first step. Now the first step in manually graphing this rational function is to determine if the graph has symmetry. Okay. So we're going to make use of the concept of odd and even functions. Now, to refresh your memory, an even function is when you evaluate f of negative x, if it is equal to f of x, then that means that um, the function is even. Now, what does an even function mean? So it is symmetric respect to the y-axis. Okay. Now, if you evaluate the function and the result is negative f of x, then that would be the function is odd. Okay, that means it is symmetric with respect to the origin. Okay, so let's find out if this function is even or odd. Okay, so this will be of use to us when we start plotting some points. Okay, so let's try. So f of negative x is equal to 3 times negative x squared all over negative x squared minus 4. So what is the result of this? So you will get, so negative x just got squared, so still the same thing, x squared, and then x squared minus 4. Okay, so this is the result. So what can we see? So it we the result is the original function. Okay, so as you can see, this one is same as this one, right? So therefore we have here an even function. Okay, so now we know that the graph is symmetric with respect to the y-axis. Okay, so that's very cool. Now we know that. And then the second step is to find the intercepts by evaluating uh, f of 0. I mean the y-intercepts, okay? So to find the y-intercepts, so let's do that. So f0 is equal to um, 3 multiplied by 0 all over 0 minus 4. Okay, so what do we get? 0 over negative 4. Therefore, this is 0. Therefore, we have a y-intercept at the origin. Okay, so have a y-intercept at 0, 0, the origin. Okay, so how about the third one? So the third step is to find the x-intercepts. Okay, so let's we're going to find the zero. So we're going to solve this um, equation. Okay, so we have here 3x squared over x squared minus 4 is equal to 0. So what do we get? We have here multiplying both sides by x squared minus 4, we get 3x squared is equal to 0. And then dividing both sides by 3, you get x squared is equal to 0. And then square root of both sides, that will be x is equal to 0. Okay, so we have an x-intercept. Therefore, we have an x-intercept at the origin. origin again. Okay, so the fourth step will be find the vertical asymptotes. Okay, so what do we do again to find the vertical asymptotes? We need to find out um, squared over what makes the denominator 0, right? So let's equate the denominator to 0. We have here x squared minus 4 is equal to 0. We can factor this out. And then applying the zero product property, we get x is equal to 2 and x is equal to negative 2. So here are our vertical asymptotes. Okay, so as you might have guessed, the next step is to find the horizontal asymptote. Okay, so let us remember the steps. So what do we need to look out for here? 3x squared over x squared minus 4. What we need to look out for is the degree, right? So the degree of the numerator is equal to the degree of the denominator. So n is equal to m. Therefore, our horizontal asymptote is at y is equal to an over bn. Now, what is an? That would be 3. And that what is bn? That would be 1. So these are our coefficients of our first terms, or what do you call this? The leading terms, right? So you have here is 3. So therefore you have y is equal to 3. That will be our horizontal asymptote. Okay, so let's plot what we know so far about this graph. Okay, let's create a let us create oh, why is it yellow? So let's not create. Okay, so okay, make another graph, another cool line right here. Hope that's horizontal enough. 1, 2, 3, 4, 5. 1, 2, 3. Then we have 1, 2. Just bear with me here. Okay, so what do we know? We know that the graph is symmetric with respect to the y-axis, right? And let us plot our asymptotes first. Okay, so we have an asymptote at -2 and +2, right? So let's draw these asymptotes right here with a red dashed line. Okay, and here also. So we also have a horizontal asymptote at +3. So that's really cool. Now we know those. Let's plot our intercepts. So the intercepts is not really that useful because we only got intercepts at the origin, right? Okay. So now we proceed to the next step, which is to plot some points um, within this area right here. So this area right here and within this area right here. So that they will guide us in how this graph behaves. Okay, so let's try. Let's substitute 1. So let's try f of 1. So f of 1 will be 3 times 1 squared over 1 squared minus 4, right? So this will be 3 over negative 3, right? So this will be negative 1. Okay, so f of 1 is negative 1. Okay, that's very cool. And then since we know that this is symmetric with respect to y-axis, so we should also have another point here, right? That is the use of the symmetry. So it's very useful indeed. So what about um, 5 if our point is about 5? So f I no, not 5 but 1.5 rather, so 3 over 2. So I already calculated it, and it's somewhere near 5, so it's 5 something, so it's right here. So you got a point here, and you also have another point here. Okay, so if we connect these points, it's like we have a parabola. It's like we have an inverted parabola, a parabola facing downwards. Okay, so let's draw that. Okay, so let's draw that. Um, okay, so there's an asymptote here. So you can plot out more. Oh, that's a very nasty line right there. You can plot out more points if you want to be really sure of how the graph looks like. Okay, so that's how our graph looks like there. So let's substitute some other values. So outside of this particular range. So how about 3? So f of 3 will be equal to, we have here 3 times 3 squared all over 3 squared minus 4, right? So we will have 27 over 9 minus 4. So you will have 27 all over 5, right? So if you do that, so if we plot that out, so 27 divided by 5, that would be around 5 something, right? So we have a point right here. So if you have a point right here, you also know that you have a point on the opposite side because it's symmetric with respect to the y-axis. Okay, let's do another point, f of 4. So 3 times 4 squared over 4 squared minus 4, right? So this will be 3 times 16. So um, 3 times 16 divided by 16 minus 4. So this would be 16 times 3. Um, that would be 48, right? So 48 divided by 16 minus 4, that's 12. So this just equals to 4. Okay, so we have a 4. We get another 4 right here. So we will also get another 4 here. So you can say that our graph behaves like this from these 2 points. Okay, we have a vertical asymptote there and like that. Oh, we touched the asymptote. That's a foul move. Okay, very awesome indeed, right? So very cool. Okay, so let's try and check this. Check if we got our graph correctly. So let's go to Desmos and confirm it. So there you have it. So that's pretty cool, right? So yeah, so that is our. So I might have gotten this point here wrong, actually. So f of 3 over 2. So f of 3 over 2, that would be so let's just calculate it. So 3 multiplied by 3 over 2 squared all over this will be um, 3 over 2 squared minus 4. So we will get 3 multiplied by 9 over 4. 9 over 4. So this will be 27 over 4. Then we have 9 over 4 minus 4. So this would be 4. 9 minus 16. So we have 27 over 4 divided by negative 7 over 4. Right? So this is like negative 27 over 7. Now, what is that? Negative 27 over 7. So that would be about 3 something, right? So not near 4. So about 3 something. So that would be negative 3 something near 4. Okay, so we got it. We got it mostly right. So it's right here. The point is right here. Point is right here. So it's still cool. Okay. So that is our graph, and yeah, thank you for watching this video, and I hope you learned something new. So again, if you have the option to graph it automatically using software, then go ahead. So, but if you don't have that option, so you can use these series of steps in order to plot it relatively quickly compared to computing every single point. Okay, so thank you for watching, and I will see you in the next videos.